Domain, range, and end behavior. Writing intervals in different notations, representing interval on a number line, domain and range, and end. So the first thing, the signs of inequality. We want to remind ourselves with the signs of inequality. So as you can see here in this inequality, A is, for example, the number. Here the point closed. Remember this, closed and open. So to remind you that closed is, we use equal sign in the inequalities, okay? And open, it's an open circle, and we don't use equal sign in the inequalities. So here A, or A is the number, and X is all what's this graph, so all what's the number line pointing. So it's X, all what's greater than A, but it's greater than or equal because it's closed. As for this one, A and the number line or the X going to negative infinity. So here X is all what's less than or equal A. This one, it's the same as the first one, but here it's open. So the number A itself is not included with me. So it's A, X greater than A, all what's greater than A, but A itself is not with me. Here it's the same as the second one. So X is all what's less than A, but A itself is not with me, so I'm not going to put an equal sign. Complete the table by writing the finite interval shown on each number line as an inequality using set notation and using interval notation. So if I can see here, it's closed, as you can see. This point is closed. Okay, so I'm gonna write in the inequality the least number or the smallest number and the X in the middle and then 2, and I'm gonna write the inequality -3 less than the X less than the 2 and see if it's equal or not. So if you can see here, -3 less than or equal the X less than or equal 2, because the X here is between -3 and 2. And when I'm going to write it in the set notation, I'm going to do braces X such that -3 less than X less than 2. Okay, I want to remind you with the sets, when we write set, that means we're writing elements. So as I don't have elements here, or I have an infinite number of elements, so I'm going to write that set, this set includes X. And this line is called such that. So this set includes X, and this line is called such that. Such that X what? Such that X is included in this inequality. So this is this way to understand how we write the set notation. But to be able to write it very well quickly, we just write, open the braces, X, then the line of such that, then repeat the inequality as it is, then close the braces. Interval notation, it's from -3 to 2, closed. Okay, remember in the last slide when we said about closed and open, here again closed, and here it's open, closed, open. Closed, we use the equal sign in the inequality. Open, we don't use the equal sign. And in the interval, if it's closed, we use the squared bracket. If it's open, we use the normal bracket or the curved bracket. Let's see the next one. The next one here, I have this one is open and this one is closed. So it's from -3 to 2, but the first one without an equal sign, -3 less than X less than or equal to. And the set notation, it's the same thing. The set X such that -3 less than x less than or equal to, and then I should close the braces. When I'm gonna write the interval part, I'm gonna write the -3 and 2, but here the -3 will be open, so it's gonna be open bracket or a normal bracket. Here we're gonna write it. We write the inequality. So if I can see here, it's closed. The 2 here, it's closed, and the arrow is going to the negative infinity. So definitely x is all what's less than 2, and 2 is included, so x is less than or equal to. Set notation, I'm going to write the set x such that x less than 2, and then close the braces. It's very important to close the braces. The interval here, I have the least point I should write, or the smallest point I should write. If I can see here, there's no number, so it's the negative infinity. It's going to negative infinity. Then the maximum is the 2, so it's the smallest number is negative infinity, and the maximum is 2. Negative infinity is always open, always open. Negative or positive infinity, infinity in general is always open. Okay, the second one here, it's open, and it's going to positive infinity. So x greater than 2, but it's not equal because 2, it's open. Then I'm going to write the set notation, braces x such that x greater than 2, and close the braces. The interval, the small point is 2, and the maximum point here, it's positive infinity because it's going to positive infinity. So it's 2 and positive infinity, and both are open, so are curved. Let's remind ourselves with the domain and range. Okay, so the domain are the x values, and the range are the y values. So for example, if I have this table, I have values for x and values for y. So if I want to write the domain, so the domain will be the 0, 1, 2, 3, 4, and 5, and the range will be the 10, 15, 20, 25, 30, and 35. Okay, another example, if I have set of points, -2 and 3, 4 and -6, 3 and 9, 8 and -10. Remember, the first number is the x and the second is the y. So the domain will be -2, 4, 3, 8, and the range will be 3, -6, 9, and -10. I have here the graph of the quadratic function f of x equal x squared. So, how to write the domain? The maximum point and the minimum point of x. So I can see here it's both having arrows from both sides, the graph having arrows from both ending sides. So that means I can have more negative values of x and more values of y to give me the more values of y up there. So the domain is from negative infinity to positive infinity. Or I can say all real numbers. Okay. The set notation, I'll write it in the same way. X such that from negative infinity, x positive infinity, negative infinity, less than x, less than positive infinity, then close the braces. And the interval, also negative infinity and positive infinity, both are open. Then the range, how to get the range. I'll see the minimum point I have on the graph. So the minimum point I have is 0, and the maximum point is also positive infinity. And 0 is here it's included with me because I'm passing through it. The graph is passing through it, or the curve is passing through it. It's a point existing here. So y is all what's greater than or equal 0. Then I'm going to write it in the set notation, braces, y such that y greater than or equal 0, and the interval from 0 to positive infinity. Okay. If you want, I can also write it in this form. I can write the smallest part, so 0 less than or equal y less than infinity. Both are okay. Then the end behavior. how I'm gonna write the end behavior. I'm gonna see here when x going to positive infinity, the part of the graph going where? It's going positive. So when x going to positive infinity, f of x also going positive. And when x going to negative infinity, f of x going where? It's going up, so it's going to positive infinity also. Another example. I have this graph here. The domain will be all x, because I still have values here and I still have values here, so the domain will be from negative infinity to positive infinity, or also I can say all real numbers. Then the set notation, it's the same thing. I'll put it in braces and x such that, and write the inequality as it is. The interval will be from the negative infinity, positive infinity, both are open. Then the range, the minimum point I have here is the zero, but in the function of exponent, 0 is not included with me, because if I put x here, anything for x here will never give me the 2 power x is 0. 2 power x will never be 0. So it's the 0 will be open here. So y greater than 0 open. Or as I said before, it can say 0 less than y, less than or equal, less than only, there's no less than or equal, less than only to positive infinity. Okay? Then the set notation, then the interval 0 and positive infinity, open both. Thank you very much. Yes, it's correct. Let's do the end behavior. The end behavior, when I'm x going to positive infinity, that's going up, the curve going up, so it's going to positive infinity. Okay? And when x going to negative infinity, this is negative infinity, the function going tends to be 0, going to be 0. Okay? Good luck.